Okay, so this is an example that will help with the problems on page 153. For number 1, I'm going to be looking at parts A and C, which will give you a hint to the other parts. In part A, we want to find the probability of a sequential roll of 2, 4, and 3. Now, the probability of getting a 2 is going to be 1 favorable outcome in 6. So this here is 1 divided by 6. The probability of a 4 is going to be identical since there is 1 favorable outcome in 6. The die has 6 sides and we only have 1 outcome that's favorable. So since the probability of a 2, then a 4, then a 3 are all independent events, the probability of that sequence is the product of the individual probabilities, which is shown here. I did it here as 1/6 cubed, which is the probability of a 2 times a 4 times a 3, and the answer we're looking for is right there. So moving on to part C, assuming a probability on arrival at an emergency room is 0.646, we are asked to find the probability that the next 4 arrivals are all emergency. The probability of emergency is 0.646. Now the probability of the next 4 is going to be the product of those, since the events are independent, and that's what we have found to be 0.174 right there. So that's it for question 1. Take a look at the rest and follow the same principles and you should be fine. Question 2 asks us to use Excel to lay out the outcomes of a 2-roll of a fair die. Now, die number 1 and then die number 2 is shown here. The first possibility for die number 1 is that it's a 1, and there are 6 possibilities of that for different combinations of die number 2. Die number 2 can be a 1, a 2, a 3, a 4, a 5, or a 6, while die 1 is 1. The other possibility is that for die 1 is a 2, and the similar situation observed when number 2 could be a 1 through a 6, and we continue that sequence. So this here represents all the possible combinations. There is no other possible combination that exists. Now here we're just finding the sum, or we're just adding this die roll to this, and then we pretty much carry that down all the way here. It gives us the same result as using the sum. So part A of number 2 is asking us to find the probability that the 2 face of the die will be equal to 7. Now this is the sum. How many times do we have the number 7 in this column in terms of adding the value on the faces of the die? We can find that using this formula, which I'll do live for you. It's a count if, which allows you to tell Excel to count within a certain range, and you tell it what to look for within that range. The range we are interested in is from here, so you click and hold and drag down to here, and we want it to tell us if this is a 7. Alright, and then Excel will count within this range here how many times we have the number 7, and it will return that value, and we have it 6 times. The number of possible outcomes is the number we have here, and we did it by counting between this cell and this cell, and we got 36 possibilities. So the probability of a sum of 7 is going to be equal to the number of successes, which is 6, which is in G3, divided by the ones in total number of outcome, which is G4. So that's what is here. This is going to be successes divided by outcomes, number of outcomes. In part B, we're asked to find the probability that the 2 faces of the die equal 11. Similar to that, we count how many times 11 appears in that range, and then we divide that by the total number. The last part is asking us to find the probability that the two faces of the die will be equal to 8 or more. So what we did, similarly, we counted how many times we had the number 8, how many times we had the number 9, 10, 11, and 12. Then you found the sum of all of this. So the number of successes will be 15, because that's the sum of how many times we had the number 8 as the sum 9, 10, 11, and 12. And once we've done that, then we divide that by the total to get the probability that it is at least equal to 8 or more. Alright, so this should help you with question 3. Translate the principles and see how it goes. If you have any questions, feel free to reach out to me and I'll be happy to assist you. Okay, thank you.